Hello friends, which among these two people do you think are more intelligent, a civil engineer or an experienced person? Today we are going to deal about this problem, a civil engineer versus an experienced person. Let's suppose the village people are given the opportunity to cut a limited amount of forest for their personal purposes. They will cut the trees into different logs and they are cut into different rectangular logs so that they can be used to make some types of beams such that it can resist the load. So the main challenge to the villagers was to determine the correct section or to find out the correct length and breadth of these sections such that the beam such produced will resist the maximum load on it. So the question was, is it good to cut the circular log into a square section or such that the depth is greater than the breadth? And if it is true, by what quantity is the height greater than the breadth? So that was the question to be found out. For the solution of the problem, there was a gathering of the people there in this forest and they hired a civil engineer from the nearby city. But the problem was that there was also a wise person among these villagers who challenged this engineer that he could solve this problem without any calculations. The civil engineer was provided with a A4 size paper and a pen to do the calculations to find the strongest section of the beam. But what this wise man did was he snatched the A4 paper given to him and started working on his idea. So we will discuss what was the wise man's idea. So I have given here the two sections of the trees. One is the square section, another is the section in which the depth is greater than the breadth. So what this man did was he had already snatched the A4 size paper from this engineer. So he have got the A4 size paper over here and he didn't have any numerical ideas or mathematical idea, but he was an experienced person. So he just found a stick nearby the forest and put it at the center, and he placed these A4 paper on this section. And with his experience, he has already estimated the section of the circular log such that the strength could be maximum. To make it more interesting, what he did was he folded this A4 size paper into half like this such that its area will be half than the original one, and he again placed these at the center. And knowing the fact that the circular log can be of smaller size, he again folded this paper the second time and get this paper and placed at the center like this. Then what he did was he placed this paper in such a way that the two corners of this paper are touching this stick like this. The first corner also touches the stick and the second corner also touches the stick. The main idea was by protruding this line of the A4 paper, we can get the section for the maximum strength. So he put another stick over here like this, which is parallel to this edge of this A4 paper, and parallel and coincident to this edge of the paper he put another stick over there. Then he moved this A4 paper from this corner to another corner, and similar to the previous case, the two corners are touching this stick, and by the similar rule he placed two more sticks coincident with the edges of this paper like this and like this. So according to him, the section closed by these sticks was the required section that will resist the maximum load as a beam. Meanwhile, the civil engineering was solving the problem and calculating and doing some engineering calculations to find out the answer. And after some time, he thanked this wise man for his wonderful result. So why did the civil engineer thank this wise man? Let's find out with engineering point of view. In engineering, there is an equation which is called the Flexure Equation, which is used to find out the maximum bending stress produced in a beam while loading. The equation can be represented like this, and the term I by Y is commonly written as Z. So stress equals to the bending moment divided by Z. So what we can see is this bending stress depends on Z, and this Z is called the section modulus. And considering B as the breadth of the rectangular log, H as the height of the rectangular log, the section modulus of the rectangular section is given by B times H square over 6. So what we can see is the bending stress depends on the section modulus for a rectangular beam, or in other words, the beam will be strongest if minimum stress is produced while loading. So minimum stress will only be produced when the section modulus will be maximum. So the strength will be maximum when the value of Z will be maximum. So what we can say is the strength, or Z, is directly proportional to B times H square, since 1 over 6 is just a constant. So as a conclusion, the strength is directly proportional to BH square. Now we can model this problem in this way. Say this is a circular log section. We can assume that this rectangular section is the strongest section. Consider the diagonal as a diameter of this log, and this is perpendicular. Considering this as a diameter D, considering this as height H, and considering this as breadth B of the section, we can see from Pythagoras theorem in this triangle we can get B square plus H square equals D square. And similarly we have got this equation, so strength can be directly proportional to B times H square. And since H square equals to D square minus B square, we can replace H square as D square minus B square. So to find out the maximum strength, we can use some concept of calculus. So if we differentiate this strength with respect to B, we will get the maximum strength. So differentiating strength with respect to B, we get D squared minus 3B squared equals 0, which implies D squared equals 3B squared, which implies the breadth equals D over square root of 3. And again, substituting B in this equation, we will get H equals square root of D squared minus D by root 3 whole squared, which will be equal to root 2 over root 3 times D. So these are the result of breadth in terms of diameter and height in terms of diameter. To find the relation between breadth and height, let's divide H by B. So the H by B ratio will be root 2, which is approximately equal to 1.414. Let's see the method used by the wise man and why does it work. He had used a A4 size paper, and from our general sense we need to know that the size of A4 paper is 210 mm by 297 mm. The property of A0, A1, A2, A3 or A4 papers is that the ratio of height to breadth is always root 2. So dividing 297 by 210, we will approximately get the value as root 2 or 1.414. And since the wise man also folded this paper in half, so if we fold this paper, the height will be halved, that is 297 by 2, which will be 148.5, and the breadth will remain the same as 210 mm. For this paper also, if we divide the longer side by the smaller side, we will again get the result as 1.414, which is square root of 2. So how many times you fold the A4 paper, the ratio always remains the same. So what his idea was, he put a stick over there and he placed this paper such that the two corners touch this line, and what he said was, if we extend the edge of this paper like this and like this, and again move this paper to this side and do the same thing, that is extend this edge to that side, then the boundary formed will be the strongest section for the beam. But why does it work? We can see these two triangles, like this triangle and this bigger triangle, are similar triangles, and this triangle and this triangle is also similar triangle. So the ratio of these two sides is also equal to the ratio of two sides, which is square root of 2. So in this section, the ratio of height to breadth is root 2, and we have already discussed the result that for the section to be strongest, the ratio of height to breadth should be root under 2. So this wise man was correct to this point. So in summary, what we can learn is that for a circular beam to have a maximum strength as a rectangular section, the depth must be greater than the width, or being specific, the height must be root 2 times greater than the breadth. So if you just want to remember the idea of cutting into rectangular section, you need not remember this ratio, but you can only remember these papers, because our mind remembers the object more easily than the numbers. So get knowledge as an engineer and apply it as a wise person. Thanks for watching.